Hello, welcome to this lesson. In this video, I'm going to solve this question I have on the screen. The question says, in a crash test, a human dummy of mass 100 kg is seated in an automobile and an over-the-shoulder seat belt is put on the dummy as illustrated in figure A. The automobile is driven at a speed of 75 km per hour to a fixed barrier and bounces off the wall at a speed of 10 km per hour in 0.1 seconds. Determine A, the average impulsive force Fa exerted by the dummy on the belt, and B, the maximum force Fm exerted by the dummy on the belt if the force diagram has the shape shown in figure B. So let's look at how we are going to solve this question. So to solve this question, we can use the impulse momentum theorem, okay, which says that force times change in time should be equal to change in momentum. Okay, we are going to use this formula here. And then the force is given to us as Fa, so we are going to have Fa times the change in time to be equal to change in momentum. Okay, but in this case the momentum will be given as mass times what change in velocity. So for us to be able to solve this question, we need the change in time, the mass of the dummy, and then the change in velocity of the dummy. And then don't forget, the dummy will have the same velocity as the car because the dummy is seated in the car. So we have the mass of the dummy to be 100 kilogram. Okay, and then we have the initial velocity to be equal to 75 kilometers per hour, and then you have to change this to meters per second. So we are going to have 75 times 1000, okay, times 1000 meters divided by changing 1 hour to seconds will give us 3600 seconds. Okay, so when we simplify this, we are going to have the initial velocity to be 20.83 meters per seconds. Okay, and then for the final velocity also we are given 10 kilometers per hour. Okay, so for this reason we are going to have 10 times 1000 meters divided by 3600 seconds, right? This will give us the final velocity to be equal to 2.78 meters per seconds, but you have to negate it because the question says the car bounced off the wall, okay, with a velocity of 10 kilometers per hour, which means that at the end the car began to move in an opposite direction. Okay, so let's say this is the wall, and then initially the car was moving with velocity u, okay, and then it hit the wall and then bounced back with a final velocity v, and then you see that the direction of the car will change, so we are going to negate the final velocity because it will be moving in a direction opposite to the initial direction. So that's the reason why I negated the final velocity. So from this point we can calculate the change in velocity, okay, which is going to be the final velocity minus what the initial velocity. Okay, the final velocity minus what the initial velocity. So you are going to have minus 2.78 minus 20.83. okay, so let's see what you are going to get. So minus 2.78 minus 20.83 will give us a value of minus 23.61 meters per second. So that will be the change in velocity. And then the question gave us the change in time, which is 0.1 seconds. Okay, so we have the change in time to be equal to 0.1 seconds. So we have everything we need to find the average impulsive force. So we're going to have Fa times the change in time, which will be 0.1, and then it should be equal to the mass times change in velocity, which will be minus 23.61. Okay, so now let's simplify this. So we're going to have 0.1 Fa to be equal to 100 times minus 23.61. That will give us a value of minus 2361. Okay, then we are going to divide this by 0.1. okay, we divide both sides by 0.1, so this will cancel out this. So let's see what you are going to get for Fa. So 2361 divided by 0.1, that will give us FA to be equal to minus 23610 Newton. Okay, this is the answer you are going to get for the average impulsive force. Okay, so let's look at the reason why it is that way. So the average impulsive force exerted by the dummy on the belt. Okay, so let's look at that. So the belt will be exerting a force in this direction on the dummy, and then the dummy will also exert this force in the opposite direction, okay, which will be the average impulsive force that the dummy will exert on the belt. So you see that the average impulsive force is opposite to the force that the belt is exerting on the dummy. So we are going to have this to be what? Negative. That's how come the answer is what? Negative. So let's take note of that. So let's look at the B. The B says that we should find the maximum force Fm exerted by the dummy on the belt if the force diagram has the shape shown. Okay, so in this case, the area under this graph here will be equal to the total impulse. Okay, and then that's a triangle, and then you're going to have the area to be equal to half times base times what? Height. Okay, let's take note of that. And then in this case, the height is giving us the Fm. Okay, and then the base, okay, is giving us the base is given in terms of what? Time. Okay, so the base, okay, will be equal to the 100 milliseconds. Okay, 100 milliseconds, and then we will have to change this to seconds. So doing this will give us a value of 0.1 seconds. Okay, so in this case, you are going to have the area, okay, to be equal to half times the base, which is 0.1, times the height, which is what? Fm. And then we know the total area in this case will be equal to the total impulse. Okay, and then we know the impulse to be change in momentum, right? Or we can multiply the average impulsive force by the change in time to get the impulse. We can do any of those two. So when we do that, we are going to get the impulse. Okay, so the area will be equal to the impulse. Okay, and I told you that there are two ways to find the impulse. We can either multiply the mass of the dummy by the change in velocity, okay, or you can multiply the average impulsive force by the change in time. Any of them will work. So let's look at that. So we are going to have, I'm using the mass multiplying the change in velocity. Okay, so we are going to have 100 multiplying minus 23.61. Okay, so let's do this and see what you are going to get. So we are going to have, let's look at the left hand side first. We have 1 over 2 multiplying 0.1. That gives us a value for 0.05. So we're going to have 0.05 Fm, okay, to be equal to minus 2361. Okay, so we're going to divide both sides by what? 0.05 divided by 0.05. Okay, so let's cancel out. So minus 2361 divided by 0.05, okay, will give us a value of, will give us Fm to be equal to minus 47220 Newton. Okay, so that will be the value for the maximum force exerted by the dummy on the belt. Okay, let's try and then use the force times what the change in time also to do it. Okay, so let's look at that. So you're going to have the area, okay, which is half times 0.1 times Fm, and then this should be equal to the average impulsive force, which will be minus 23610, okay, times what? The change in time, which will be times what? 0.1, right? So we are going to have 0.05 Fm, okay, to be equal to, let's do the multiplication, minus 23610 times 0.1, that will give us a value of what? Minus 2361, okay, divided by what? 0.05 divided by 0.05. Okay, so this will cancel out this, and then you're going to get what? the maximum force to be equal to minus 47220 Newton. Okay, let's take note of that. Thank you very much for watching this video.